Good morning, boys and girls. It's another day with the Barefoot Teacher. Anyway, I hope things are going well for you. I hope you had a beautiful weekend. And I hope that you are taking some time to just relax and hang out and do the things that you love. So, what we're going to do today is a game called Mythological Liars. It's a play on words. A pathological liar is somebody who lies all the time and sometimes doesn't even realize that they're lying. Mythological liars are a little bit different. I will be reading you a case number, and it will tell a story of something that happened, much like when we play the game Alibi, where somebody comes in and tells us of a crime that has been committed and everybody tries to tell their alibi. Well, this is the same thing, but the way we know who the criminal is that they've done something wrong in the math, and that's how we know that they're the guilty party. So we're going to do two of them today, and I'm going to talk about some of the ones that I'm sending you, and you'll be receiving a worksheet like this one, and you can try them out. My hope is eventually, after we do enough of them, that some of you will be really creative and extend the project and actually come up with a crime and some cards for yourselves. And you can share them with us, and maybe the classes can do them together. So, again, it's Mythological Liars. If we look at the worksheet, it asks for a case number. And then each case has 4 people that give alibis. So let's take a look. It'll be much clearer as we actually do one. All right. So this is case number 4. And it looks like a detective's case file. And here is the case of the escaping ants. Someone left the lid off the ant farm in Mrs. Logan's class. Now the place is crawling with little black critters. Mrs. Logan wants the culprits to round the ants back up. Who left the lid off the ant farm, and how do you know? And I guess I should take this moment to say, sometimes there's more than one culprit. Okay, so the first person is Lucy. So we write Lucy's name up here. Then it asks if she's the liar, if she's the mathological liar. And then it asks, how do you know? How do you know? You can either fill in with words or you can show us the math. So Lucy says, I was on the playground. I was arguing with Susie, and I said only 1/5 of the swings were empty. She said that 0 2/10 of the swings were empty. Wrong! That girl can't count. So now it asks us for the math understanding. In this case, it's going to be more than, less than, or equal to fractions and decimals. So if we look at 1/5 and we look at 2/10, we can rewrite 2/10 as a fraction. Now maybe some of you can look at that right now and say, oh, I can tell what's going on. But if not, remember, if we have the same denominators, we can tell. So you can do one of 2 things. You can make an equivalent fraction to compare these two. And if that's what we want to do, we would multiply by 2/2. And we would get 2/10 and see that these two were equal. Okay? Or if you recognize that 2/10 divided by 2/2, if you wanted to simplify it, equals 1/5, again, you would see these were equal. Let's see what somebody else says. I was in the cafeteria. This is Zoe. I was in the cafeteria. The lunch lady asked me to put 3/4 of a cup of ketchup on every table. But the last table, there was 8/10 of a cup left. I'm lucky that there was more than enough for the last table. So she was filling cups up 3/4 full, and she needs to make sure that there's more than enough if there's 8/10. Again, let's see. 8/10 and 3/4. Well, we can simplify 8/10 if we want to. We could divide by 2/2, and that would be 4/5. If you can't recognize if 4/5 is greater than 3/4, you can always find equivalent fractions, and their least common multiple would be 20. And we would multiply by 5/5 and get 15/20, and 4/4 and get 16/20. And so Zoe said, I'm lucky that there was enough, more than enough left over. And there was. We could take 3/4 out and still have some left over. We could actually have 1/20 left over. So that was true. Okay, case number 4, and this is Tran. And Tran says, I was in the science lab. The teacher asked me to add 1/2 cup of plant food to the watering can. I carefully measured 5/10 cup of food and added it to the can and watered the plants. That's exactly what she told me to do. So if it's exactly what she told him to do, then these two should be equal. If you already recognize that 1/2 and 5/10 are equal, great. If you don't, you can look and say, well, this is equal to 5/10, and since I know that 5 is half of 10, it is equal to 1/2. And if you don't recognize that, maybe you can see that these can both be divided by 5/5, and we would get 1/2. If you didn't think to do that, you could find an equivalent fraction. And in order to go from 2 to 10, we would have to multiply by 5/5. And we could prove once again that they are equal. And finally, Sylvia. Okay, I'm not allowed near the ant farm. Last week, Mrs. Logan told me to add a 1/4 cup of water to the farm. I carefully measured 0 4/10 cup. And she said I was going to drown the ants. I measured exactly what she told me to. So if you recognize a relationship between these two, you can write it down. If not, you know that we can change this to 4/10. And we can do a lot of things. We can simplify this by 2/2, and we would get 2/5. But we still, if you don't recognize if this is larger or not, because remember, if the teacher accused him of drowning the ants, that must have meant he added too much water. So again, if you can't recognize, let's find common denominators. So their least common multiple would be 20. And then what would we do? We could multiply that by 5/5 and get 5/20, and we can multiply this and get 8/20. So yes, in fact, he put too much water in. So let's go back now that we have all the math done and see who was lying. So Lucy, remember, she was on the playground arguing with Susie. I said only 1/5 of the swings were empty. She said 2/10 of the swings were empty. Wrong, that girl can't count. Okay, so both girls were correct. Therefore, Lucy saying, wrong, that girl can't count, makes her one of the liars. Her math was incorrect because, in fact, they were both equal. Let's look at Zoe. I was in the cafeteria. The lunch lady asked me to put 3/4 cups of ketchup on every table. By the last table, there was 8/10 of a cup left. I'm lucky there was more than enough for the last table. Was there, in fact, more than enough? Yes. So Zoe isn't the liar. Her information was correct. Then we have Tran. Tran was in the science lab. The teacher asked me to add a 1/2 cup of plant food to the watering can. I carefully measured 5/10 cup of food, added it to the can, and watered the plants. That's exactly what she told me to do. And that is, in fact, because they're both equal, that's in fact true. So Tran can't be the liar. And let's look at Sylvia. I'm not allowed near the ant farm. Last week, Mrs. Logan told me to add a 1/4 cup of water to the farm. I carefully measured 4/10, and she said I was going to drown the ants. I measured exactly what she told me to do. Now, since these two are not equal, he did not do that, so he is, in fact, the other liar. So our two liars in this Mythological Liar game are Lucy and Sylvia. Now, there's not always two, and sometimes there can be 3. So when you're looking at it, go carefully through each one of them. So this was something that had to do with equivalent decimals and fractions. And you had to remember that we have that a number that looks like a decimal like this can actually be written as a fraction 2/10. So those are some things to keep in mind as you're working. Some of them are easier, which is actually the one I meant to start with, but let's take a look at another one. They get harder as they go along. Runaway tape. We ran out of regular tape at this house, so I have to use packing tape. All right, so again, we see our worksheet that we're going to work off of. And I just wanted to give you another opportunity to hear what each of the liars or each of the people in the case were saying. So if you don't want to go back and read them after you do the math, you can just decide whether they're the liars right from the start. All right, this is actually case number 14, and we're going to be talking about understanding inverse relationships. So if you remember inverse relationships, addition and subtraction are inverse relationships, multiplication and division are inverse relationships. And this is case number 14. Okay, so it's the case of the laughing lion. The Central City Zoo has a problem. Every day the zookeeper tries to teach visitors about how dangerous the lion can be. This week the lion laughed. The audience laughed with the lion. The zookeeper needs this to stop. Who is making the lion laugh, and how do you know? So we will start with Ellie. Okay, remember this is understanding inverse relationships. I was too busy counting the people in the crowd. There were 100 people over 5 days. So that is 100 divided by 5 equals 20. Or the inverse operation of 20 times 5 equals 100. So you have to decide, is Ellie correct? Is her math correct? 100 divided by 5 is 20, and 20 times 5 equals 100. For Ellie, that means if there's 100 people over 5 days, that was 20 people a day, or 20 people a day times 5 would give us 100 people in 5 days. So do you think that's correct? Yes, it is. So she's not the liar. Remember that we're asking the question here. Is she the liar? Okay, let's look at Nick. Okay, Nick bought popcorn every day. There were 150 kernels in each bag. Can you guess how many kernels popped and how many didn't pop? Well, here's the clue. 150 minus 17 equals 133. Or you could say 133 plus 17 equals 150. So you have to do the math and see if he's correct. You can either try the subtraction or try the addition because you know the digits are set up correctly for the inverse operation. So let's do 133 plus 17, and we would get 10, 5, 1. So he is correct as well, and so Nick cannot be the liar. Okay, let's look at Dina. I was standing by the lion yard, but I was looking at the penguins. They are across from the lion. I kept track of how many times the 3 penguins dove into the water each day. So it was 9 times 7 equals 63, which is the same as 9 divided by 7 equals 63. Okay, so we have to look at Dina's math. Is that correct? 9 times 7, yep, that is 63. And so what she could say is they dove into the water 9 times in 7 days, and that's 63 times altogether. And then we look at this, 9 divided by 7 equals 63. Well, that's not correct. 9 divided by 7 is the same thing as saying 9/7, and hopefully you would understand that that would be 1 and 2/7, which wouldn't really make sense for this problem. So this is not correct, so Dina is one of our liars. We can't stop here though because we have to see if the next person, Jason, is lying also. So now we have Jason, and Jason says, I've been to zoos in 27 out of 50 states. I've never made a lion laugh. In case you don't know, 50, the total number of states, minus 27, the states he visited, is 23 states that he still needs to visit. And he knows that because 23 plus 27 equals 50. Now, if you don't recognize that right away, hopefully you'll be thinking, oh, well, if I took 2 off of here and made that 25 and added 2 onto here and made that 25, I know that 25 plus 25 equals 50. But you might want to just set it up like your addition algorithm, and again, you can prove that it's 50. So since Jason is correct, he is not the liar. So our liar in this case is Dina. The hardest part, I think, is when someone is correct, you want to check off yes. But remember, they're asking, are they the liar? And you're proving that they're the liar because they've done something incorrect on their work. Try a few and see how that goes. And if you're really into it, maybe you could create a case for yourself and send it on to me so I can see. That would be a little extension of the lesson if you have time and creativity. Okay. The other thing that I want to just discuss with you is I want you to take a quick look at our March calendar, and I know that you won't see it clearly. I'll be taking a picture of it, but I want you to notice things about the pattern, and tomorrow or later on this evening when it's dark, I'll take a picture of it, and I'll be asking you to write down patterns that you see, things that you'll be expecting for the week of the 11th. Now, you know, I already sent you day 11, and I really want you to figure that out. And again, tomorrow morning, later tonight or tomorrow morning, I'll be back on there to say, okay, what did we get for 11? This is what you should have gotten. And then how can we extend the pattern? All right, boys and girls, that's it for now. I hope you have a great day, and we'll see you tomorrow. Thanks.